Hey guys, it's your friendly neighborhood engineer back with another lesson on tritium. Um, this one will be about some comments that were made on a physicist channel in the comment section. We won't be scrolling through the comments, we're just going to be reading one that is a general notion of most of them anyways. Okay, what you see before you is what naturally occurring tritium is extremely rare on the Earth, and the atmosphere has only trace amounts. Okay, so I want you to keep that in mind as we read the next comment. Okay? So you say that natural cosmic radiation creates no tritium? No, that's not what I say. What I say is that the naturally occurring U-235 is surrounded by the neutron capturing U-238 and isn't concentrated like it is in our fuel, in our reactors. And that's why we get synthetic radionuclides that do not exist in the environment, in the universe, in any measurable quantities. That's what I say. Not that it can't be formed by cosmic radiation in the upper atmosphere, right? In a natural reactor, water moderated, right? A natural reactor would be water moderated, but in a reactor, it's not only water moderated, but also with control rods, right? And those are made from various materials, boron and other stuff, okay? Has totally different decay products, right? Okay, okay, exactly. Because our reactors are not water moderated too, right? No, it's not. See, he goes on this whole spiel and not even understanding what I said. So we'll just go skip all this because he didn't even understand it. Or they, he, she, whoever. Okay. No primary source of tritium is cosmic radiation. Well, as the average dose hitting atmosphere over such a gigantic area that is Earth's surface dwarfs any really rare tritium in reactors, just by the sheer size of the area it's happening. And again, no, that's not what we just read. We just read that naturally occurring tritium is extremely rare on Earth. The atmosphere has only trace amounts of it. So no, the atmosphere doesn't have all the tritium that's on planet Earth. It's rare, okay? So he says tritium is tritium. If cosmic tritium enters the boidy, and by far the most tritium getting bound in organic forms is cosmic, which is untrue, we just read, it becomes organic tritium. And you will have, see, they don't even know what they're talking about. It's not organic tritium, it's organically bound tritium. There's a difference. And you will have not the slightest chance to be able to tell if organically bound tritium is of natural or artificial sources. Well, that is very untrue. That is very untrue. Because here we see the Vogel, Georgia 2007 study that clearly shows how we can see how much tritium is coming from this reactor, right? And not only that, annually, this is from memory, annually, nuclear reactors emit tens of thousands of terabecquerels annually. So we know exactly how much tritium is coming from our reactors. So this person has no clue what they're talking about. None. And they're trying to tell me, the engineer, exactly how this works. So since my comments wouldn't place on Elena Taratsidu's channel, this person was allowed the last comment and made it look like I lost the debate. But then I put, that didn't post, natural nuclear reactors are not even the same as our reactors. Do you know why there are synthetic radionuclides not found in nature in any measurable quantities, including OCLO? Yes, I know the exact name. It's because the U-238 neutron captures the much smaller concentrations and doesn't allow it to chain out like in our reactors. No, you're wrong across the board. I said because it's not just about tritium, although it does permeate metal and cannot be contained, and why the very sought-after fuel for fusion is just thrown into the environment. Hey, do you know how tritium can be filtered from the water? Do you know how expensive it would be to filter tritium from the water? Just ask TEPCO, that's using the ALPS, which is a water treatment filtration system for nuclear energy, how much tritium they are able to filter. Fukushima alone probably has as much tritium in those tanks than what you would naturally occur on the surface of this planet. Not in the upper atmosphere, even though it's rare up there too, in a certain time frame. Yes, anyone that knows anything about fission or fusion knows exactly where tritium comes from, and you're not saying anything to me that I haven't already known for decades. Everything you know about tritium up until you went on a tirade after being asked a very simple question is what you were told to repeat and nothing more, parrot. Edit, carbon-14, krypton-85, and xenon-133, iodine-131, Ru-106, iodine-129, iodine-129, cesium-134, 137, and much more are released every single day in the fluence of normalized discharges. The amounts do not matter once ingested. The Peckow effect due to the bonding. Once bonded, it's a whole life dose, and exposure at any point. Tell me what specifically causes each cancer, being that ionizing radiation exposure even at low doses causes cancer. Where's the list of cancers that breaks down all the specific causes of these cancers? Autoimmune diseases, respiratory diseases, cardiac diseases, and more, all caused by exposure to ionizing radiation, even inflammation. Show me those lists of every death, what the diseases was that killed them, and most importantly, what specifically caused those diseases. You don't know, nor has anyone in the history of the planet, and exactly where all the nuclear power deaths are hidden. And that is true, guys. See, I'm saying, no, I'm not saying that natural cosmic radiation creates no tritium. I'm saying that the sun creates the tritium from fusing hydrogen atoms and helium atoms together in the radiative zone outwards to the convection zone, where it takes a single photon up to 100,000 years to escape it. Sorry. I'm saying that the magnetic field, LLBL, and the L shell blocks much of that, and then what does enter the upper atmosphere, what's left after that, most doesn't make it down to the surface of the planet, which we just read. Okay? So, let me show you guys something. This is a chemistry student. Let's see what he has to say about the matter. What this guy is saying is semi-plausible. He's talking about me. Since tritium is hydrogen with 2 extra neutrons and organic chemistry is carbon chains with hydrogen attached, tritium could bond with the oxygen to make tritium water, then get taken up by the plants to make whatever organic molecules plants make. That would make an organic molecule with one or more of the normal hydrogen atoms replaced with tritium, making a radioactive organic molecule. But it's still really bonkers because a similar portion of the carbon in organic molecules are radioactive anyway, so it really makes little difference, and the tritium would likely decay in the time that is formed in the reactor, released from containment, floats around, waiting to react with oxygen, then precipitating out to be collected by the plants and made into organic molecules, then eaten to do any damage. The half-life is just not long enough. And I say, it doesn't matter what it would likely do. There is new research on exactly what it does do. And I quote, tritium once ingested can form organically bound tritium that either replaces hydrogen in the cell or binds directly to the cell to form organically bound tritium. This can cause DNA strand breaks, micronucleus formations, cell necrosis or apoptosis, chromosal aberrations, and various other phenomena, thus negatively affecting human health. This isn't a hypothesis. This has been proven in the lab, which is the only place we can test it, since we can't test on humans after all. then this is, oh, they had it, yes. Also, half-life means in 12.33 years, half will be gone. In another 12.33 years, half of what's left will be gone. In another 12.33 years, half of what's left will be gone, etc. Half-life doesn't mean safe at all. You have to understand, a brand new tritium radionuclide is the same, exact same, as one that has been in existence for 12.33 years. It's the same. You can't tell them apart. Half-life does not mean safe, guys. It just doesn't. Because of the Vogel study. Here we go. This is where it tells you tritium can directly or indirectly induce various biological effects, including DNA strand breaks, blah, 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 blah. As I said. Oh, and here's the terabecquerels. I did put it in here. Nuclear power plants that can each emit up to tens of thousands, emit up to tens of thousands of terabecquerels of tritium annually. Annually, guys. So you see, these people are out here pretending that they know what they're saying. And then you got physicists that know better that are allowing them to do it. Yet they're said to be open and honest and unbiased. Come on, please. What do you think? Tell me your thoughts down below. All right, guys. Bye.